This is the last property, periodic property, which is called electronegativity, and it is represented by the symbol chi. Chi means it is like X. Already you have got mole fraction also represented by this chi symbol. Electronegativity also represented by chi symbol. So what is electronegativity? It is the tendency. It is the tendency of an atom to attract the shared pair of electron towards itself in a covalent bond. And it is represented by chi symbol. I'll explain it. Suppose a covalent bond is present between hydrogen and hydrogen, and how the covalent bond is formed? Covalent bonds are formed by sharing of electron. This hydrogen contain one electron, that's why it is unstable. This hydrogen also contain one electron, that's why it also unstable. When it gain one more electron, then it gets the helium conversion. That is why it has the tendency to attract one electron, and that's why this hydrogen attract one electron from it, this hydrogen attract one electron from this, and this is called the sharing of electron, and sharing of electron always produce covalent bond. Now in the formation of covalent bond, this electron is attracted by this atom, and this electron is attracted by this hydrogen atom. Here the attracting power is same or different. Since both the atoms are same, that is why attracting power is also same, and in this type of case, the electron, when it produces the bonds, the electron are present in the middle position of the bond. But suppose a bond is present between hydrogen and chlorine. As you know, hydrogen contains one electron, chlorine contains 7 electrons in the valence shell. As you know, valence shell involved in bonding formation, that's why I have written 7 electrons. Due to presence of 7 electron, it requires one more. And due to presence of one electron in hydrogen, it also requires one. So hydrogen will attract one electron from chlorine, chlorine will attract one electron from hydrogen, and it produces the covalent bond. Now here the attracting power of the atom are same or different. Chlorine attract more or hydrogen attract more. That is called the electronegativity. I mean, it is the tendency of an atom to attract the shared pair of electron towards itself. So since chlorine configuration is 2H7, due to presence of 7 electron, it has more tendency to attract the electron, and that is why when the covalent bond is formed between hydrogen and chlorine, the electron is more come towards chlorine like this, due to more attraction by chlorine, and that is called the electronegativity power. I mean, chlorine is more electronegative than hydrogen. Have you got it? What is electronegativity? Electronegativity means it is the tendency of an atom to attract the shared pair of electron towards itself in a covalent bond. So this electronegativity property is not for isolated atom. This electronegativity property is always for bonded atoms. I mean, when some atom produce bonds with some element, then you will get this property, and you don't get the direct value of electronegativity. Electron gain enthalpy, ionization enthalpy, you will get the value. Which atom have how much energy it will release or require, directly you will get the value. But electronegativity have no such value. It is measured in a scale. I mean, it is the relative tendency, how much attraction than this, like that this electronegativity is measured. So electronegativity means it is the tendency of an atom to attract the shared pair of electron. And electron gain enthalpy is, it is the energy released when a neutral atom gain one electron to form the anion. Electron gain enthalpy is the property of isolated atom, but electronegativity is the property of bonded atom. Electron gain enthalpy value is normally measured in kilojoule per mole unit, but electronegativity value do not have any unit. So these are the point of differences between this electronegativity and this electron gain enthalpy value. Now Electronegativity depends on number of factors, like it depends on hybridization of the atom. Since you don't get hybridization in chemical bonding chapter, you will get the hybridization, then you will get in details. So it depends on the hybridization of the atom, you will get later. It depends on the oxidation state of the element. Oxidation state means the charge of an atom. For example, FeCl2, FeCl3. This is called ferrous chloride, this is called ferric chloride. Here the charge of iron is 2 plus, here the charge of iron is 3 plus. That charge is called oxidation state. So here iron contains 3 plus, here iron is 2 plus. I mean their oxidation state of iron is 3 plus here, oxidation state of iron is 2 plus here. If the oxidation state of the atom increases, the electronegativity of the atom also increases. I mean here Fe3 plus is more electronegative than Fe2 plus. That is why electronegativity value of an atom is not fixed. It depends on the condition. Iron may be more electronegative in some cases, iron may be less electronegative in other cases. So that is why electronegativity of an atom is not fixed. But electron gain enthalpy value, since it is the property of isolated atom, so electron gain enthalpy value for an atom is fixed. Chlorine, this much electron gain enthalpy value, fluorine, this much electron gain enthalpy value. But electronegativity property, you will get different for an atom in different compounds. So it depends on hybridization state, it depends on the oxidation state of the element, and it depends on number of factors you will get later. Since you don't get about oxidation state and hybridization state, so that is why you will get later. Now, how it changes along a period and in a group. When you consider a period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So since its configuration 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Since from left to right size of the atom going on decreasing, so that is why the attraction towards electron going on increasing, and that is why electronegativity from left to right in a period it going on increasing. Noble gases is exceptional, they have no such electronegativity value. Fluorine is the highest electronegative element in this period. Not only in this period, in our modern periodic table, the highest electronegative element is fluorine due to presence of 7 electrons in their valence shell. And when you consider a group, from down the group, as you know, size of the atom going on increasing, and due to increase in size, electronegativity of the atom going on decreasing. I mean from top to bottom, electronegativity decreases. So in a period from left to right, electronegativity going on increasing due to decrease in size, and from top to bottom, electronegativity decreases due to increase in size. I mean size and electronegativity both are inversely proportional. If size is more, electronegativity is less. If size is small, electronegativity will be more. And in our modern periodic table, fluorine has the highest electronegativity value, and electron gain enthalpy, chlorine is the highest one in our modern periodic table, then oxygen, like this way. So in exam you will get the question like this: what is electronegativity? I mean the definition, how it changes along a period and in a group, and why. I mean why it decreases from top to bottom, why it increases from left to right in a period. So that type of question you will get. What is electron gain enthalpy? How it how it changes along a group and in a period. Like this, you have to write the definition and the variation, and you will get the series of elements. You have to arrange the elements in order of electron gain enthalpy value, in order of their electronegativity value, in order of their sizes, that you have to know. So as I have given number of factors which can affect electron gain enthalpy, ionization enthalpy, if you know about that factor, then you can find out which atom have higher value, which atom have lower value, and like that way you have to arrange it. So this is about the periodic properties of elements. Thank you.